Hello everyone, welcome back to Kanai's Lab. Today, we were diving into a real-world problem, predicting energy consumption. Whether you are managing your home's electricity or working on an energy-saving project, predicting energy usage based on different factors is superb useful. We will use Excel and linear regression to predict the energy consumption. Look at the sample data set we have, energy consumption data. So we are going to predict the energy consumption based upon different factors like temperature, humidity, wind speed, solar radiation, number of occupants, applicant usage, and day of the week. We will be calling as all these columns colored in green color as our attributes or dependent variables. And this energy consumption, we will call it as our target or independent or dependent variables. So we are going to compute energy consumption based on the attributes given here. So how a regression works? Regression model find the relationship between the independent variable or features or attributes and the dependent variable. So the regression formula is y is equal to b0 plus b1 x1 plus b2 x2 plus b3 x3 plus etc. b and xn, where b0 is the intercept and b1 b2 etc. bn are the coefficients of the given attributes. Look at the below image. It represents a linear regression between two variables, that is x and y. We have only one attribute and we have the target of y. In this particular problem, you can see the colored dots, which is blue, which is nothing but our actual y values. We have actual y, we will call it as y1. This is y1 and this is y2 and this is y3, y4, y5 and y6. You can see here, if you have multiple points on a plane, how do we draw the line? You can draw line like this, or you can draw line like this, maybe passing through maximum number of points. So it's very clear, if you have a point coordinates on the space, you can pass infinite number of lines. That is math, nothing magic. So we can draw infinite lines. Then I can see only one line in this particular problem. How it is possible? That one line, it depends upon one particular criterion, that is have minimal error between the points. So this line, this black line, we will call it as a regression line. It's basically based upon minimal error square, we will say that. So what basically happening for line number 1, it will compute one minimal error square. How it is computed? It is the difference between yi minus y hat, and we will be squaring it. This is summing for all the point from I equal to 1 to 6. So you can see here we have all the yi, and this is nothing but, we will call it as the red color, we will call it as a y hat. This is y1 hat, this is y2 hat, this is y3 hat, etc. etc. So basically the difference between y1 and y hat, we will call it as residual. So we have residual 1, residual 2, residual we have up to 1 to 6. So this is nothing but sum of squared residual. We will search sum of squared residual. So it computing from 1 to 6, sum of squared residual approximately, if it is 0.6, error. Similarly, line number 2, computing its 0.8, etc. etc. Imagine this algorithm work for 100 lines. It produces something called 1.4. You can see here the minimal error is for line number 1. For an example, this is just a case only, may not be on the first line itself. Here we got line 1 has the minimal sum of squared, that is SSR. So hence this line 1 is our best fit line. So this regression will be works with best fit line. This is for line number 1, our case study. So like this, we will be computing the regression, And the next question, suppose we computed line like this for the regression, how can we say that this is the best fit line, or how do we measure the performance? For measuring the performance, we have some kind of metrics. We can say that metric, we have mean absolute error, we have mean squared error, RMSE root mean squared error, and we have R2 or R square. How do we calculate mean absolute error? You have yi, you have y hat, and take the absolute value and average it. That is called MAE. MSE is nothing but instead of taking absolute, it's squaring it. What is RMSE? It's a square root of mean squared error. Then how do we interpret? So for the best model, we need less error. So that whenever the error is going less, we can say that model performance is increasing. Whenever the error is high, we can say that model performance is decreasing. So this representing the error in terms of a number. Now, then what is R2? R2 value is always, we'll call compute in between 0 and 1. If the R2 value is approximately 1, we can say that this is going to be the best. And if the R2 is approaching to 0, we can say that this is a worst model. So we will be computing R2 or MAE or MSE or RMSE to check the performance of the regression model. That's all the concept of linear regression. By the way, remember, for the best model for linear regression, there is an assumption the variable should be linearly related. So with that assumption, we are moving to the prediction of energy consumption using the variable of temperature, humidity, etc. For that, we are going to go to one particular option, go to data. You can see there is a particular tool called data analysis. Maybe in your Excel for the first time, you may not be able to see that. How to enable that? Go to file, then explore the option more. You can see an option here. So click on to the add-in option. Then you can see here, go. You need to enable whatever you want. In this case, I need analysis toolpak. I'm just clicking OK. It will update your data ribbon with the package of data analysis. Now we are going to use this data analysis. Within the data analysis, I'm going to use the regression. Click on to OK. Now you can see here, since I already run this exercise multiple times, I have all the input, but I will tell you what is the input. I need input y range first. What is my input y range? You can see here that's correspond to column H from 1 to 101. And what is your input range? You can see here my input range is from column number A to column number G, including observation from 1 to 101. So since the column header is available, I'm going to click the column levels. I need the output in the new worksheet. Let me run this. You can see here input. I need to check it again, it seems. Let me rerun this. Input Y range for me, it is column H from 1 to 100. Now, I'm going to take the value of A. Going to take the input X range. For that, I going to drag the column from temperature to day week from the observation 1 to observation 100. Simple. So click enable label and show the output option. Now run the exercise. Definitely it is going to create some output. Now you can see here a lot of input are there in this particular sheet. We may not be needed everything. We are not going to in-depth statistical analysis on this particular result. We just need how it is performed. As I mentioned, as an output, we need intercept B0 and B1 corresponds to first column of X1, B2, B3, B4, B5, B6, B7. We need all the intercept and the coefficient. Let me copy this. So I have a prediction separate tab. Going there, I'm just copying and updating the value of B0 to B7. See, it is updated. Now, so this is randomly checked. Tell me what is your humidity. I'm checking starting from temperature itself. So if my temperature is 18 and the humidity is approximately 28 and the wind speed is I'm putting 3.2 and the solar radiation 420, some numbers, number of occupants 2, applicant usage kilowatt hour is 0.9, 0.9, and I made the day of the week of first day of the week. You can see this is updated. This update is happened based upon the equation intercept plus temperature value coefficient 0.06 into 18 plus 0.021 into 28, etc., up to 1 into minus 0.307. This energy consumption is going to predict based upon that. Now, suppose if I'm going to change this slightly to 7, let me not here. So I'm going to, sorry, there is an equation error here. Let me check once again. So I to B9. So here this is going to change it. This is going to update the equation. 1 second. So A1, A2, B2, I don't want E2 here. It is C2. Then D2, E2, F2. Yeah, it's working now properly. Now I'm going to update this number of occupants to 7. So this is updating here only. It's C2 again. So this is here. Now here I am changing number of occupants to 7. Let me see whether the prediction is changed. Yeah, its energy consumption is reduced. We don't know whether how it is related. As a linear combination of x1 to x7, we have the values of y. But individually, we don't know how x3 is related, how x4 is related. So with that, we predicted regression using Excel by using the data analysis tool pack of Excel. Now let's see one last check onto the sheet where the output or the regression summary output is there. How to interpret this? I can see here there is an option of identifying what is my error and all. You can see here this nothing but the correlation between the variable. This is nothing but we'll call it a small r. Now we don't know this. And we have r square value of 0.34. This approximately 0 correspond to 0. So it's going to not a good model. It's approximately a based model only. We can't say based model. It's not a good model because it's greater than 0. That's good, but not reaching to 1. Adjacent r squared, another parameter is minus 0.03. Standard error is 5.25. There is 99 observation. So we have this kind of information from the regression statistics. And one good thing you need to check it out. What is the p-value of the entire activity? Something we will call it as a p-value. This is a parameter in statistics. So with the assumption, the p-value should be less than 0.05 with 95% of confidence interval. So the parameter, whatever it is, 0.85, which not coming less than 0.05, we cannot take this particular method is significant. So statistically, this regression is not significant. The reason could be the non-linear data, and another reason could be less data points, and another reason could be quality of the data. Since it is generated data, quality of the data. So might be if the quality of the data is good, actually, if you are going for a real-time data, if you have more data points and the quantity of the data, quality of the data is also good, and if it is linearly related, this value is going to reduce less than 0.05, then you can say that your regression model is significant. And here also you will get the r squared value something bigger than this. So that's how we normally interpret our linear regression. So with that, we are going to conclude our linear regression analysis using Excel Toolpak. We just wanted to recap. We learned what is regression. We learned what is best fit line. We learned how to measure the performance of the regression line, how to conduct linear regression using the regression function of data Toolpak. how to interpret a linear regression and how to improve the quality of the regression. So please note that we cannot say that all the data points work well with all the regression or any of the algorithms. It depends upon the data. It depends upon the algorithm. Keep exploring, keep trying with different models with the different data. So you will be able to do a good prediction. So with that, we are concluding. Thank you so much for watching this video on predicting the energy consumption using linear regression. Stay tuned for more informative content on Kanai's AI Lab.